Okay, good afternoon everyone. Welcome to the IP addressing and network IP design class. Okay, so this is our course outline for today. So first of all, we are going to learn about the layer 3 identifier, which is the IP address itself. Now, identifier means something to recognize a device in. Like for example, if you need to communicate, even as humans, right, we need to call you as a name, some name, so that when we send our message across, we send it and direct it to a correct person. So same as in the network, we also need an identifier so that when the packets or messages are sent or packets are sent to these nodes, then they also need a name, or in this case, we will use IP addressing. So that is the layer 3 identifier that we are going to learn today. Okay, and the IP always comes together with a subnet mask. There is a reason for the subnet mask. The subnet mask, normally an IP, just like our address, is hierarchical. Our home address, for example, number 6, Jalan 2, Taman Mega, and then you have your state, and then you have your country. Yeah, so that is called a hierarchical address. So number 6 is your house number, and then the rest would be your location and your country. Now, in an IP address, it's the same thing. The IP address is a hierarchical IP address where you have portion of it is the location of that IP, and then the address of that host itself. So just like number 6 is the house number, but if I just say number 6, right, you don't actually know where the location is. So I have to give you the other parts of the home address so that you will know where to find that house. Okay. Now, and then in the IP addressing itself, we do have different types of address like network, host, broadcast address, which I will go into more details. We have to have a technique of calculation to calculate out the network address, to calculate out a broadcast address for a certain network. Okay, and the calculation of network size, there is a formula that we can use to calculate how big is the network size given this IP and the subnet mask. Yeah. And we have different type of IP addresses. So one of the type would be private IP, public IP, and we also have classful, classless IP address and other types that I'm going to cover as well. Yeah. And how to configure IP address for the host or the device. Okay, first of all, IP addressing is a numerical label assigned to each device so that they can communicate with each other. Okay, so we have talked about OSI layer model, yeah. So whereby there is an encapsulation at every layer. So from the application layer, you create data. Then after that, you send it to the transport layer that will put in a header. So that is called encapsulation. So every time you add in a header, now in that header fields, there will be some addressing plus some other control fields. Yeah, and IP address is encapsulated at layer 3, where it's in the network layer. So at the network layer, you insert an header, and in that header would be the IP address. Okay, now IP address serves two main functions. One is the host ID, the host itself, the address itself. The other one is location, like just what I explained just now, yeah? So how can you imagine it out in the network topology? So you can see that this is the network address telling you where the host is in. So this is the network address. So it's just like our home address just now, we have Taman Mega. So, your home is in Taman Mega, so we know the location. But then, which one especially is your home? Then that would be the specific IP address of that node itself. Okay, so that IP address would be found inside the range of this network. So we will calculate later on when given a certain IP, what is the network range, what is the network address, and there's another address which is what we call the broadcast address. Now, every network, right? Every network, or we call it subnet, would have a network address with a mask, subnet mask. And inside this network would have many IP addresses of hosts. And then we have one address called the broadcast address. Now, this broadcast address is specific for each network. That means this network would have a different broadcast address compared to this network. And that specific broadcast address is an address whereby if you send it to this address, it will be sent to every device in that network. So that's what it's called a broadcast address. Okay, I believe you have seen examples of IP address. So 188.18.18.1. Now we call it dot and not point. Yeah. Normally they like to read as point, right? 192.16. No, it's dot. It's just like www.abc.com. We don't call it www.abc.com. Yeah, call it dot. And this is a decimal. Decimal, dot, decimal, dot, decimal, dot, decimal. So that's why we call this format as a dotted decimal format. Okay? So another example, 192.168, which you always see, .1.103. Okay, one of those very popular private IP address. Yeah. And then 173.45.3.22, 8.8.8.8. This is actually Google DNS IP. Yeah. And 10.1.1.100. This is also quite a popular private address. Okay. So where can we see IP address in a host? Now, of course, this is a Windows laptop. You can type ipconfig command, IP configuration. So you type ipconfig and out comes the list of interfaces, because IP is attached to an interface. Yeah. So whichever interface that is active, you should see an IP there. Whichever interface that is active, you should see an IP there. So you can see my Wi-Fi is active. So, and the IP is 192.168.101.24. And IP must always be specified with the subnet mask. If you have an IP only without subnet mask, there's no meaning, right? You cannot figure out what is it. So it must always come with the subnet mask. So therefore, you can see subnet mask like this, 255.255.255.0. And then I do have an Ethernet cable connection. Okay, and it's 192.168.127.110, and the subnet mask is 255.255.255.0. Now in Linux, before you go to Linux, if you need to look at more configurations on a certain interface, you can type ipconfig/all. Okay, now ipconfig/all would not only give you IP address, but it will give you the MAC address as well. Now, MAC address is also another identifier, but that one is in layer 2, okay, which we will not discuss today. Okay, and yeah. So in Linux, you can type ifconfig, interface configuration, or IPADDR. And how do you know it's an IP address? You look for the dotted decimal format. So inet 10.0.2.15 mask 255.255.255.0. It even calculates for you the broadcast address here for Linux. Yeah. And if you look carefully, there is also a MAC address there. MAC address is 12 hexadecimal, and with this format. So it's under ether 08 colon 00 colon 27 colon 5D colon 77 colon 3B. Okay, so the class prior to this we discussed MAC address. So then you should be able to recognize the MAC address. Yeah. Now let's go into IP address again. Now IP address actually is specified in binary. It's just that we represent it in decimal. It's because of human, right? We like as a human to read decimal. Yeah. But in our device, it's actually in binary. So every decimal here is represented by an 8-bit binary. So just now we saw 172.16.254.1. So 172 you convert to 8-bit binary. It's 10101110. Now, 0, 0, 16, 0, 0, 1, 0, 0, 0, 0. Now, how do we convert? You can actually use our PC, find calculator. Yeah. Under programmer, now of course, this is Windows calculator, you have standard, oops. It doesn't show out there. How do I, maybe I need to stop slide. End slideshow. And then, yeah. So if you open up the calculator from your laptop, you can, for Windows laptop, then you have standard scientific and graphing, you have programmer, so you choose programmer. And you just click 172. Now Windows calculator would immediately convert for you in 8 bits binary. Okay, so you just take 10101100, and then you convert each of the decimal by its own separately to 8-bit binary. So therefore 172 is 1010111016, and then 254 is all ones except 0 at the last bit, and 1 is all 0 except 1. So each decimal is 8-bit binary. So if you have 4 decimals, 4 times 8 is 32, yes. So basically the length of an IP address is 32 bits. 32 bits. Yeah. And we count every one of set of 8 bits as an octet. Octet means 8. So 8 bits. Yeah. So just now, our so many decimals, we can actually convert each one of it into its binary equivalent or format. Yeah. So maybe each person just take one of the IP and do the conversion. Yeah. So the first one, 188.18.18.1, maybe Yixin, then Mingyi, Zhenghao. Oh, 8 is very easy. All 8. I'll skip that. You have to do the difficult one, 10.1.1.100. Okay. Using calculator is quite fast. Yeah. Okay, let me just take a sample of answer. Okay, 192. Oops. Okay. 192 is 1 1 0 0 0 0 0 0 dot 1010 dot 0 0 0 0 0 0 0 1 dot 103. 0110. Sorry, and then 0 0 1 1 1. Okay, so that is 192.168.1.103 in binary. Thank you for this answer. So you can see the range of every octet is all 0 to all ones, correct? So therefore in decimal is 0 to 255. So therefore you can have technically 0.0.0.0 IP up to 255.255.255.255. So in a sense, every decimal that you see here, the range would be from 0 to 255. So therefore, if you look at one of these decimal, it cannot be more than 255. Yeah, it's from 0 to 255. It cannot be more than 255. You don't have 256 or 272. Okay? So that is how the binary range is for each of the IP. Okay? Now, just now when we were doing the ifconfig commands, we see that every IP will have to come with a subnet mask. Right? So what is the meaning of this subnet mask? So subnet mask will help us to divide the IP address into two portions. Okay, just now I said that IP address is hierarchical. Hierarchical means you have a section telling you about the location, and the other portion is telling you about the ID of that host. Yeah. So subnet mask is used to do this, to separate it into two portions. So network ID represents the entire network where this host comes from, and then the host ID represents that specific host. Yeah? So subnet mask is used to determine the network ID and host ID. So example, 192.168.1.34, and just now we saw in the ifconfig, the more popular subnet mask is 255.255.255.0. So if you take the IP and then you use the operator logical AND operator A and D operator with the 255 subnet mask, you actually will get the network address. Yeah, but in this case, it's actually written in binary. So you have a binary just now, and then the 255 subnet mask would be actually 1111, 1111, right? And you have three sets of the 8-bit 1111, right? I have no space here, but I'm just drawing it into the next row. So if you take that and you operate it on our address just now, yeah? So our address, let's take it from this slide, 1.34. So 192.168.1.34. So this converted to binary would be 110, 100, and this is 00000001, and 34 would be 001, 00001. 1, 2, 4, 8, 16, 13, 10, sorry. Okay, so that will be 34. And then you operate it with a 255.255 mask, which comes as a binary representation, 8 sets of 1s and 0. So what it actually means is you actually use an AND operator, logical AND operator. Now, logical AND operator works this way. 0 AND with 0, you get 0. This is the symbol for AND operator. 0 AND with 1, you have 0. 1 AND with 0, you get 0. 1 AND with 1, you have 1. So therefore, anything AND with 1, 1 AND with 1, you get 1. 1 AND with 1, you get 1, is a bitwise operator, which means you do it bit by bit. And 0 AND with 1, 0. Okay. 1, 0, 0, 0. And then this is 1 AND with 1, 0, 1, 0, 1, 0, 0, 0. Can you follow? Yeah. And then 0, 0, 0 AND with 1 is all 0. Anything AND with the 0 would be 0. 1 AND 1 is 1. And then 0, 0, 0, 0, 0, 0, 0, 0. So that is what you get. Now, if you analyze, whatever AND with 1, it is back to the original. So 11001000 end with 1, you get back 11001000 dot. Yeah, and then same 168 is 1010, you end with 1, you get back the exact same binary. And for 1 in binary, you end with 1, you get back 1. And anything end with 0 becomes 0. So basically, when you convert this back to decimal, you will get back whatever the 255 are. Whatever all the ones are, you will get back the original decimal. And whatever end with a 0, you get a 0. So from 192.168.1.34, you basically get another address which looks like this. Okay, so this is an IP address, and you activate using the mask. That means you end with the mask, subnet mask. You get what we call a network address. So every IP you see with a mask, you use the AND operator, end it on the IP, you will get its location. So this is a node address, and that is the location. Okay? So how do you then represent it as the network part, the network part and the IP, the host part? Okay, from here, all the one that has the 255 mask, that would become the network part, because later on when you find that you end with the mask, you will get back this in original. So this part is what we call the network ID, and this portion is called the host ID. Okay, now we will see more examples of this. Yeah. Now next slide shows you what are the other subnet masks that you may see. What are the other subnet masks you will see? Now of course most of the time we see the 255.255.255.0. Okay, so that is in dotted decimal notation. However, if you look at the newer iOS, yeah, they also specify it in what we call the CIDR format, or we call it the prefix format. Prefix or CIDR. CIDR stands for classless inter-domain routing. Okay? /24. So what does that mean? Okay, basically you just need to count how many ones in that subnet mask. So just now our subnet mask, which we convert to binary, right? So we see is 8. 255 is 8, 1 bit here. The other 255 another 8. Then another 255 another 8. So basically 8 times 3 is 24. So therefore it's /24. Okay, there are also other subnet masks like 255.255.0.0. So if you convert this to binary, it will be 8 bits of 1, 8 bits of 1, add up together, 16. So it's /16. Okay, another example of mask is 255.0.0.0. So that only one decimal 255 you convert to 11111 will be 8 bit of 1, so /8. You will see some other subnet mask as well. Example 255.255.192. Okay, so the first set is 8 of 1s. Next one is 8 of 1s. 192 is 11000000. Okay, so therefore 8 plus 8, 16, plus 2, 18. So /18. Yeah, you may see this mask as well, 255.255.240.0. So basically, if you add up all the ones there, it will be /20. Okay? Now, if you analyze all these masks, all the ones start from the left. So let's just take this one. So all the ones are start from the left. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. That's the first set of 255. And then the next set of 255 is 1, 1, 1, 1, 1, 1, 1, 1. And then 192 is 1, 1, 0, 0, 0, 0, 0, 0. So if you analyze 255.255 just now that we had, it also has this type of pattern, yeah? So you have like 1, 1, 1, 1, 1, and then another 8 ones, and another set of 8 ones, and suddenly it becomes 0. So you can see from the left is all ones, and then when it turns to 0, all is 0. That means there is no random, suddenly you have a 0, 1 here. So you have all the left ones, and then the minute it turns to 0 is all 0. All the left ones, the minute it turns to 0 is all 0. You cannot have random 0 here, random 0 there, or random 1 here. Okay? Now, the reason why it is like this is because it actually means all those bits, the IP address bits that you end with a 1, you just take it as original from the left. And then after that, when it turns to 0, change and flip that bits to 0. Okay? Example, yeah? So I have, let's say, an IP 10.8.8.8. So if I change this to binary, it becomes 0, 0, 0, 0, 10 is 1, 0, 1, 0, and 8 is 0, 0, 0, 1, 0, 0, 0. Yeah? Let me try to erase this. Okay. Then another, 0, 0, 0, and another 8. Okay, then if I activate it using this mask, let's say 255.255. So what it means is you have 2 sets of 8 here. So you pair it up with your mask according to its bitwise location, yeah? You follow the location. Then you find that all those that pair with 1, you basically have back the original, you get back these original bits, and then whenever you activate with the other mask that is all 0, whatever bits you have here, it will be turned to 0. So basically, what it means is all the bits from the left, you count how many to keep as original, whereas all after that once, you turn it and flip it all to 0 because binary is either 0 or 1. So basically, your address is 10. So if it pair with your 1, it will be original. But if you then activate with all the 0, the binary becomes 0. So basically, you are actually calculating how many bits from the left that you are going to keep as original, and then the rest, flip it to 0. So that's the meaning of mask, yeah? How many bits from the left in an IP that I keep as original bits, and then after that, on the right, flip everything to 0. So the one on the left that you keep, it becomes the network address portion, or the network ID. Okay? Now, we call it slash because, have you played this game called fruit slash? Just now we eat fruit, right? So you take an IP address, count how many bits from that mask, then you slash that IP into 2. The left, keep original, that is the network ID. The right, change everything to 0. Yeah, that would become the network address. But if you just slash accordingly, then you can see the network portion and the host portion. Okay, so for example, 192.168.1.112, yeah. Now, slash 24, we know that this 8 bits, 8 bits, 8 bits, so it's slash just at that decimal. Correct? So, this portion is what we call the network ID portion, and this other portion is what we call the host ID portion. Yeah. So if you need the network address, you just make this become 0. So the network address is 192.168.1.0. So how do I write the network address? It's just 192.168.1.0/24. So that is my network address. And 112 is one of the hosts in my network. Right? Now next example is 10.1.1.3. So 10.1.1.3/16. Now 16, we know that the first 8-bit, second 8-bit, you keep original. So that would be the network portion or network ID. And this 1.3 is the host ID. And if I want it to be represented into a network address, that is 10.1. These two, after the slash, after the mask, 111 bits of mask is 0. So therefore, that would be my network address, so /16. Okay? Now, if you have a /29, then you know that this is 8-bit, 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 24, 29 somewhere between here. Yeah? So it gets a bit tricky because now we got to represent it in binary to be able to see it. Yeah? So therefore, 192.168.12, that would be 24 bits. Now I need to slash another 5 bits from this IP, right? Because if I slash up to here, it's only 24. So I need another 5 bits from 210, right? Can someone help to change this to binary 210? Okay, 1101. 0010. Okay, thank you. So you have 5 bits from here. So 1, 2, 3, 4, 5. So this portion up to here is the network ID portion or the network part. And then the 3 bits behind here would be the host ID or the host part. So how do I represent it in the network address? Is when all the host parts become 0. Okay. So, okay, I'm going to write it on top here. So you have 192.168.11010 is the one we slashed just now. And we said that the network portion or the network part must remain original. You don't change the bits. So therefore, you have the last 3 bits where you can flip to 0, and that would be your network address. So therefore, my network address would be 192 in decimal. We change back to decimal, you get 208. Okay, I missed a bit. /29 is our network address. Yeah. And 210 is one of the node address inside this network. All right? Can? Okay, then the last one, yeah?
So you can slash until 32 or 32 is the maximum.
Correct. When you slash 32, that whole thing becomes actually the whole net. Yeah. Slash 32 actually is one host. Correct. So sometimes when you see a /32, that is the address itself for that node. Okay. So it's 202 to the last example is 10.10.10/30. Okay, /30. So basically up to here is 24 again. Okay, so therefore we keep this as original and then break 10 into binary. And you /30 is up to here, right? Because 32 bits is the maximum, right? So up to here is the network portion. And you have only 2 bits for the host ID. So if I change it to network address, it becomes all 0. So it becomes 202.10.10.100.8/30. Yeah. So if you break this network / this IP, you can see the network portion and the host portion. Host portion make it into 0, you get the network address. Okay? Any questions so far? Okay. Now we come to the classes of IP address. Yeah. Now IP addresses divided into 5 classes. You have A, B, C, D, E. Okay. So which IP address belongs to which class? It is specified by the first few bits. Yeah. So let's just look at the next slide first. So how do I classify an address into class A when your binary first bit is 0? It's quite easy, straightforward. If your binary first bit is 0, it's class A. How do I classify into class B? Binary 2 bits, first bit is 1, 0. So that's a class B address. How do we classify into class C address? It is first 3 binary is 1, 1, 0. Class D, 1, 1, 1, 0, first 4. Class E, 1, 1, 1, 1. Okay, so let's go back to here. So class A, B, and C is the one we use in the network. Yeah, for unicast communication. Okay, now class D is reserved for multicast address. Multicast address. Yeah, and then class E is for experimental, so we don't use it actually. Now, when you divide into class A, B, and C, okay, that is in binary, right? So if you try to imagine it in decimal, now class A start with 0. And we know that the first octet, the first 8 bits can be 0, 0, 0, 0, 0, 0, 0, 0, up to, I still start with 0, but the rest is 1. So therefore, our first octet will be 0 to 0, 1, 1, 1, 1, 1, 1, 1. Now, if you need to convert back to decimal, you can still use the calculator just now. Okay, and then you click to binary and you change it to, just now was, what was the question just now? Yeah, 0, 1, 1, 1, 1, okay. So 0, 1, 1, 1, 1, 1, 1, 1. Okay, so 0, 1, 1, 1, 1, 1, 1, 1 in decimal is 127, right? Okay, so therefore, this is actually 127, not 126. Error here. So therefore, our class A would be from 0, but there's no 0 address lah. Okay, so they put it as 1 up to 127. It is not 126. Okay, so this is up to 127. Okay. Now, class B starts from, just now if you look at the slide, it has to be 1, 0, start from 1, 0, the first 2 bit. So 1, 0, and we know that it is 8 bits. So therefore, the first octet, if you complete the 8 bits, would be either all 0 to 1, 0, 1, 1, 1, 1, 1, 1. So using back the calculator, you would get the range is 128 to 191. Yeah. And then the last one would be 110. So complete back, complete into 8 bits, and complete this into 8 bits, you will get 1922223, right? So therefore, if you look at this address, all these addresses, you can classify them according to their classes. So by looking at the first octet. Now, if you like to convert this to binary, then you can use the binary representation and then classify according to the first bit or the first 2 bits or the first 3 bits. But then if you like it to be in decimal, then you know the range of the first octet. So 188 would be class B. 192, C. 173, B. 8, A. 10, easy, yeah? Okay. Now, every class, this is what we call a classful address. That means you can classify the address into a certain class. Then every class have their own default subnet mask fixed, no change. So if you have class A, your default subnet mask is 255.0.0.0, that means /8. Fixed, huh? If your class B address, your subnet mask fixed 255.255.0.0 is /16. If it's class C, is fixed 255.255.255.0/24. And you always see this in the network. Whenever you do an IP configuration, IP config, you'll see, hey, this is my network address, my IP address with that mask. Even you go home, right? You have your unified connection or Maxis broadband connection, and then you check your IP address of your laptop or your PC, it will come out 192 something and 255.255.255.0 is the class C address. Okay, so then every class with its own fixed subnet mask would have its own fixed how many network portion bits. So class A /8, so the first 8 bits is the network portion. The last 3 octet is the host ID portion. Okay? Class B /16, 16 network portion, the other 16 host portion. Now they call it portion bahagian lah. Okay? So sometimes they call it information lah, sometimes they call it ID lah, sometimes they call it network part lah. Same lah. It's just the part you slash already. This part become the network, the other part become the host part. So in CIDR format or prefix format, /8, 16, /24. Okay?
To steal your student for a while.
Okay. Can. Kena stolen. One student. Okay. Okay, now, these are all the nodes, yeah. Now, class D, we don't use it for communication. We don't use it for unicast communication. That means for putting, configuring IP address on the node. Because class D is for multicast communication. Yeah. So you have seen multicast address like 244, 224 dot something and 239 dot something. Yeah. That is multicast. So what is the meanings of multicast? Yeah. Now unicast is one host sending to another host. We call it 1-to-1. From one host sending to another is 1-to-1. 1-to-all is broadcast. One host sending to everyone. Now multicast is 1-to-several. Now you see multicast address being used in routing protocols like OSPF, which is next level already. Yeah. So the multicast address is in class D. So a multicast address will start with 1110, the first 4 bits. So therefore, if you convert to the range, you will see it's from 224.0 to 239.255.255.255. Now, E is not used for us. This is for experimental purposes. Okay, so therefore, just to summarize, class A/8. So the first octet network, 3 octet. After that is the host part. Class B/16. So the first 2 octet network portion, last 2 octet host portion. Class C, first 3, because it's /24, is the network portion, and the last 1 octet is the host portion. Okay. Now, all this network has its size. The size of the network depends on the length of the mask. Okay, let's start with our class C. Class C/24. Or in dotted decimal format, our mask is 255.255.255.0, which means out of the 32 bits, you have 24 bits network portion, and 8 bit is the host portion. Now, this portion, the network portion, is the network address, but the 8-bit portion would be the node IP addresses. Yeah? Now, if you have 8 bits, that means it's going to start from 00000000 to a combination of all 1111, 1111. Correct? Which means it's from 0 to 255. So if you count how many values are there from 0 to 255. Okay lah, 0 to 3. How many? 0, 1, 2, 3. So 4 values, right? So that means 3 plus 1, right? So it's 0 to 255 is how many? 256, correct. So therefore, how many nodes we have here, or how many IP node ID is 256. So it's given by this formula, 2 to a power of how many host bit you have. So you have 8 host bit, it would be 2 to a power of 8. Yeah. Okay, so using back our calculator. Yeah, correct. So that's how we get the size. So go to scientific, 2 power x power y, 8 equals 256. Okay, so guess what is the network size for class B? Yes. Correct. It's 2 to the power 16. 65536, right? Yeah. Because why? The mask 255.255.0.0 is slash 16. So basically, you have 16, which is the network portion, and 16 bits left would be the host portion, correct? So you have 16 host bits. Host bits, you have 16. So therefore, 2 to the power of 16. Now, class C just now, you have slash 24. Slash 24 means 24 bits network bit. So you left 8 host bit, correct? So 2 to the power of 8, 2 to the power of H is 2 to the power of 8, which is 256. Now, class A, how big is this network? Yeah. Your scientific calculator may give you the answer. Our normal calculator, I think, exploded. Yeah, it's 1.6 something million. So that is how many hosts you have in the class A network. Because why? The host bit is 24. Because this slash 8. Slash 8, that means 32 minus 8, you have 24 bits left. So how many bits for host? 24. So you have 2 to the power of 24, 1 point something million. So when you design a network, right, you look at the network size. If my network is only 80 devices, you will use a class C address. If my network is 1,000, you may use a class B, but you will waste a lot of address because you have actually a total of 65,000 address. Yeah. Now, of course, class A is used in the public network, in the global network. We don't use it in the private network. It's too big. So that's the reason why whenever you do an IP config in any of your laptop, you will see a class C address. Because our private network, LAN, we don't design it to more than 200 over device. For us, 200 over device in a LAN is a very big network already because there will be a lot of broadcast traffic. So normally for LAN, you just use a class C. Okay, so which one of the class C? Anyone that is in the range just now. Okay, now the problem of class full address is like just now we did was our class A is like how many million? Or class B is like 65,000. What if my network is only 1,000? I still want to use a class B address, but it will be too big for me. I can't use a class C. It's too small. So that is another type of address is where we call it a classless address. Okay, classless address. Because there's a problem with the classful address. It's too big for our use. So classless, quite easy, not difficult. Now, we just calculate our mask exactly to the size that we need. And that mask is called prefix. Right? The slash mask is called prefix. So we calculate the prefix exactly to the size of the network we need. So if I need a network of size 300, right? So just now we know that the size of the network would be 2 to a power of how many host bit, correct? So if you equals it to 300, right? So we know that to the power of h, the nearest to 300 would be, now, h, 2 to the power of h. 1, 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3, 8, 16, 32, keep on times 2, 64, 128, 256, 512. So that is the nearest, largest 2 to a power of which means it's 512 network. Okay, so our H will be 1, 2, 3, 4, 5, 6, 7, 8. So our host, 1, 2, 3, 4, 5, 6, 7, 8, 9. So our host bit will be 9. So therefore, if host bit is 9, what would be our prefix, yeah? So we know that our total network bit is 32. You only need 9 host bit. So what would be the mask size here? So 32 minus 9. So this is slash 23. So basically, we can design a network with the mask slash 23. So it becomes a classless address. Because classful address will follow slash 8, 16, and 24. So if I design a network with slash 23, it becomes a classless address. Yeah? Okay, do we need a break? Aaron just have his break.
Continue.
Continue?
Depends on everyone.
Okay. Can? Okay. Now, just now we say we want to design using IP address. And I know that, okay, our size of the network is normally class C. So, then which address do I choose? Which one? So many. So, there is what we call a private and public IP address range. Yeah. So, private IP is where we use it in our private organization. Public IP is where you can see from the internet. The public IP address are those IP that we use in the internet. Okay? So how do we define these two? Okay, the private IP is something that you cannot route that IP out to the internet. It cannot be seen in the outside world. You keep it private. That's why it's called private. And then the public IP is where we use it to route across the global internet. So there is a range for private IP and there's a range for public IP. Okay? So the range for private IP is this. So you have class A. If you use class A address, the range has to be from 10.00 to 10.255, which means you cannot use 11. Now 11 is still class A. Why? Because 11 is still between our decimal 0 to 127, remember? So the first octet 11, that means you can actually use 8, 7, which is class A, right? But you cannot use that as a private IP address. So the private IP address for class A can only start to be used within this range. You can only use this range. So even if you like 12.11, you're not allowed to use it. Okay? So anything out of this range would be the public IP. If you want to use a class B, you want to design using a class B, which means your address in your network is like 3,000 hosts. Then you got to choose a class B. So class B address for private use can only range between 172.16, 0 to 31. So that's why you don't see 173.15 being used in a private LAN. You don't see 172.15 because it's out of the private IP range. And the most common is class C. So that's why every time you see a class C, how come always like 192.168? It has to be. Because 192.168 is the only private IP address given to you to be used. So you go to any private network, you see the private network, if they use class C, is 192.168. But of course, you can choose between .0 something, .1, .2, .3, up to 254. Yeah. Even 255.0 can still be used. Yeah. So when you do a design of the IP for your nodes or for your network, you must keep this in mind. Yeah? You have no choice, you just have to choose from here. Okay, now let's go a bit on network design. So I choose my IP address range. I choose my mask according to what I need for the network size. Now, we can use classless address in a sense I can choose from a class A private range, but I use the mask which is not class A. Class A's mask is /A. But because my network size is like 200, less than 200, so I can still use /24. So it becomes classless. It doesn't matter as long as it's in a private range and as long as your mask is according to your network size. Then, if I use this network, right? So this network address, then what are the range of the IP that I can have in my network? Yeah. So how do we calculate that? Now, network address is when all the host bits become 0. Broadcast address is when all the host bits is 1. Okay? And then anything in between these two is the IP address that we can use to design for the host. Okay, example, yeah? Example. So I have this 192.16.10.1. Now, this is actually not a private IP. It's just an example. It's not a private IP range. Remember, our private IP range is 192.168. This is not actually. But we are just using it as an example. So 192.16.0.1, if I /24, it means that the first 3 would be the network part and the last decimal is the host part. If I change the decimals all to 0, that would be the network address. And if I change all this host bit to 0, now host bit, when we talk about host bit, is actually binary. Yeah? So this binary is 0, 0, 0, 0, 0, 0, 0, 1. If I change it all to 1, it becomes all ones. So therefore, my range would be 0.255. So therefore, we have 192.16.0.255. So this would be the broadcast address. We call it the last address in the network. So now, given any IP with a mask, I can calculate the network address and I can calculate the last address, which is the broadcast address. The network address is the first address. The broadcast address is the last address. Anything in between is my host IP address, which means .1 to .2, .3, .254 is all those IP that I can use to design for my devices in the network. Okay, now back to this, my network size is depending on my mask, right? So if my mask is /24, which means 24 network bits and 8 host bits. So 2 to the power of 8 is 256. So I have 256 address. And the first address is the network address. The last 255th, that means it's 256, right? Would be the broadcast address. Then in between would be 254 addresses that I can use to design for my host. Okay? Yeah. So my host I can put as .1, .2, .3, .4, .200, .251, .253 until .254. Then 255 cannot be used for a host because that 255.255 is specially for broadcast to everyone. It's for everyone. Belongs to no one, but it's for everyone. Network address is also for everyone. Belongs to no one, but it's for everyone. You cannot take a network address and configure as a host. Cannot. It doesn't work that way. So that network address is like a taman. Your taman mega, yeah, it's your address, but it's not belonging to you. Right? It's not your address, house address. So there are 2 addresses in the network that you cannot use to design for the host. So that's why if you calculate how many possible hosts in the network, you take the full network size minus 2. Why 2? First one is the network address. The other one is the broadcast address. So now if you do any IP config in any of our device and you see the mask and you see the IP, you can actually calculate the network address and the broadcast address. And you can actually know the range of the IP for all the other nodes. Right? Can? Okay. Let me ask you, is a /29 network larger than /16 or /16 larger than /29? Which network is larger? This one or that one? 16 is larger. Which means when your mask is longer, your network is smaller. Why? Because the host bit is less. So /29, your host bit is only 3. So you have 2 to the power 3. 8 total IP. 6 total nodes IP. So if you see a /30, you always see /30, especially when you look at network topology. /30, how many total IP? 4. Because you /30 means you have 2 host bits left. So 2 to the power 2, 4. And out of the 4, one is network address, the other one broadcast address. That means you have 2 more left IP. So therefore you have only 2 IP left, right? So where do you see the /30? The engineers will see it. You all will see in your packet traces. Router to router. You use it for connection only. Because /30 has only 2 IP. Correct? Let me find space. /30. You have 2 IP. That means if you design it inside a network, you only have 2 IP to be used, So normally you see the /30 would be the connection, router to router connection. And why you use /30? Because you don't want to waste any more IPs. You just need a /30 address. So that's why when you see in the network topology, you see /30 is a connection, /30 is a connection, /30 another connection, 2 IP only. Normally it's router to router. So if you design a network, right, you can use a /30 for connections router to router. You don't have to choose a /24 because the smallest class C is /24, but we can actually use classless. So you choose a /30. Okay. Okay, the rest are kept as exercises so you can actually calculate all this Given any address, IP you see with the mask, now you can calculate the network address, broadcast address, range IP for hosts, total IP address for the whole network, number of possible hosts, which means you take the total minus 2. So now we are going into the section called IP address design. Okay, so just now we already know about IP addressing, we know about the classful IP, and then we know what is the subnet mask is for. And the subnet mask is used to separate the network, the IP address into the network portion and the host portion. And we also did calculation for the network addresses, broadcast address, and the host of the IP range of address that we can use. So now, how do I design addresses for a network if I have a network? So first of all, in order to design the network IP address, we need to determine the network address that we want. Okay, and once we have a network address, we also would want to know the mask, because then we would know the size of the network. And from that mask, we will know all the broadcast address and the range of the IP that we can use to design for the host. Now we call that type of IP usable IP. Now remember, in the network, we have 2 addresses that we cannot use, because it's a network address to determine the network location itself. The other one that we cannot use is the broadcast address. So then the rest can be used. So those that can be used, we call it usable IP address. Okay? And then when we design IP address for network, we must make sure and check thoroughly that all these addresses must not overlap with any one of the address in another network. And no two hosts should have the same identical IP address. Okay? Now, for internal network, which we design most of the time, we will use the private IP address range, the range that I showed you just now. And before we start choosing any IP address to use, we first of all analyze the size of the subnet needed first. And then from the size of the subnet, we determine whether we should use a classful one like the /30 or classful one class A, B or C, most of the time it's class C, or the classless, which is /30 for connection. Okay. Now, one example. So let's say we would want to design for this network. So the first thing, of course, we analyze how many total IP for every one of these network. So you can see it's 50, example is 80, 100, 200 is considered big for internal network. So the largest size here is 200. So basically, which class address can we use? Class C. Because if to recap, class A, 1 point something million, that's the size of the network. Class B, 65,536 hosts. Class C, 256. So if you look at the size of the network we have, the maximum is only 200. So we will choose a class C address. And then which class C address should we choose? Now, go back to our slide just now. It has to be from the private range. So the class C, 192.168.0.0 range. Okay? However, because we are using a /24 subnet mask to indicate the size, because this network size 256, right? If we opt to use classless address, that means we do not follow the class and its range plus the mask, we can actually use 172 as the network IP as well. You can use a 172.16.0.0/24 as well. It is not wrong. You can still use it as long as it is within this private IP range. So sometimes when you go to a certain private network and then you do an IP config to see the configuration, you can see, oh, they use a 172 address. But it's /24, it doesn't matter. Now, let's go back to a class C. Let's say it's 192.168. So how do I choose what network address to put here? So we have 4 subnets here. 4 subnets. So if I use a private C address and I choose 192.168. It starts from 0.0. Now, 0.0 means your network address is 0.0. Your broadcast address will be 0.255. And anything between here would be the range you can allocate for your host IP, we call it the usable IP. So it's 0.1 up to 0.254. So we call this one block of block C. We call this one block of block C. That means from 0.0 up to 0.255 is one block. Then the size of this network is 256, right? Now, the next block of block C would be, take this at 1 is 1.0, correct? So therefore, you have the next block is 192.168.1.0. And it's 1.0 network address, 1.1 up to 1.254, and the broadcast is 1.255. So the next third block will be 192.168.2.0, then 3.0, 4.0, and so on, right? So now you see you have 4 subnet here. You can actually choose any from all these blocks. They would not overlap. They won't overlap. So if I choose 0.0 for this subnet, 2.0 for this subnet, 4.0 for this subnet, 6.0 from this subnet, and you analyze the IP that you are going to allocate to all these nodes, right? They will not overlap because they are in their own block. Can you see? Okay, so let's say if I choose 2.0 for this guy, so you know that the IP will be 2.1 inside here, would be, okay, let me choose 2.0 lah, /24. So therefore the range would be 2.1 up to 2.254, right? And I choose 192.168.4.0 block for this guy. So I know that the IP will be 4.1 to 4.254. And you know that any of this IP here would not overlap with any of this IP here. So that is okay, right? So basically, if you choose block by block, it is all right. It would not overlap. So if I say this 1.0, 3.0, so then you can already design IP addresses for your subnet. Okay. Then within this range is where you choose which one to put for your laptop lah, your PC lah, switches lah, and router. Okay. So that depends on your own design. That depends on your own design. You can choose your own design. Now, normally for ease of management, right, we will set like, for example, we know that for this block is 1.1 up to 1.254. You can set apart 1.1 to 1.10 is where I will use it for my routers and switches. You can do it that way. Or 1.200 to 100 to 1.200. That would be for my laptop and PC or my other nodes. Yeah. And then .201 up to .254, that would be for my servers. It's up to us to design. Okay. Now, for ease of maintenance, people normally choose the first IP address, .1, or the last IP for the router interface. It's just ease of maintenance choice. It's not like you have to always use the first IP, no. Or you have to always use the last IP for router, no. It's just that it's easier. If every network is the first IP, then you know that every network you go, every subnet, you know the first IP is my router. Right? Yeah. So sometimes they will set a range of my servers will be the last IPs. So when you see, oh, 200, it must be a server. So it's more for us to design that way. Okay. So normally we try not to randomize things like for example, suddenly your switch is a suddenly is .8. Suddenly this one become .1 and then this one is .9. So it's like your IP is so random that when you see an IP, you do not know what device it is. Right? So you have to go and check everyone. Or this IP is which device, this IP is which device. So it is very confusing to manage such a network. So it's better to block it yourself. This range is definitely, when I see this range, .1 to .10, I know it is one of the router or one of the switch. Or .1 to .5, let's say if your router interface is not that many, or your switches and routers in the network is not too many. So every time I see a .1 to .5, I know that is the router and the switch. And every time I see a .100 to possibly .200, okay, that would be the user's PC or the user's device. Yeah. Okay, another example. Now you have a network that is too large for us to use, but it's just for example. It's 2,000 here, 1,000, 5,000, 2,500. So which network address would you want to choose? Yeah, class B. That's the easiest. Okay. So any class B private. So basically class B use /16. So any private range. So now you got to look at blocks of /16. So you got to be careful in the sense that the first two is the same but the last two decimal is different. So let's say if I choose from any private range, let's say I like 172. So if you look at 172 private range would be 16 to 31, right? So I can choose 16. So 172.16.0.0, the first subnet block. Now the next subnet block is 17, right? Is 17. And then the other next subnet block will be 18.0.0. And then you have 172.19.0.0. So you have 4 subnets. And all this, if you look at the ranges, it would not overlap with each other. Okay? Because the first network, the first address is network address. The last address is a broadcast address. So it's 16.255.255 is the broadcast for our first subnet. Second subnet is 17.255.255. Third one, 18. So we know that the range in between will not overlap with each other. Yeah? So you can choose that way. So, guidelines for network design. Allocate certain range for routers and switches, more for ease of maintenance. And then allocate another range for servers and important critical network support devices. Like your firewalls, network admin PCs, you give them a certain range. And the other rest of the range, you put it for user. Yeah. Now, if we implement VLANs, yeah, then each VLAN would be considered as their own subnet. So therefore, each VLAN is its own network. So contoh, example, if you have VLAN 10, VLAN 20, right? So VLAN 10, same thing lah. You look at your VLAN, how big your VLAN should be lah, how many hosts in the VLAN? Same So VLAN 30. So if I have, there's less than 254 devices or same, then you can use a class C /24. Then make sure your block that you choose is not overlapping lah. So let's say it's 10. Now normally for ease of maintenance, if your ID is 10, we try to make it 10 so that when you see a 10 dot, you know it's VLAN 10. It's no hard and fast rule. It's just that it's easy for us to know our network. So when you see an IP address, you know, oh, it's from VLAN 20. Where's dot 20? And then it's 30. Okay, it's VLAN 30. 40, that is VLAN 40. Yeah. And we know that once you choose address with a mask, you will know its ranges, network address to broadcast, and make sure no overlapping. Okay. So once we have already designed, chosen our network addresses, designed the range, and we design every node to have their own IP, the router, which range of IP they have, switches, and so on, then we can assign IP address. Yeah. Now, 2 ways to assign IP address. One is statically configure IP address, that means manual configuration. The other one is using a server called DHCP. That is called dynamic IP address. DHCP stands for Dynamic Host Configuration Protocol, is a server. So there is a DHCP server who will assign addresses automatically to device. Yeah. Now, when do we do static IP address assignment is for those important devices that cannot have a change of IP address. Yeah. So like for example, routers, you cannot have the router changing its interface IP from time to time. So we have to statically configure for that router. Or switches, static configuration. However, dynamic is most probably given to the user. The user, when they enter a network, maybe today they get 10.100. Then they log out and they log in again, they may get 10.101. So they have a running IP. Okay, for user, we normally use dynamic IP configurations. But for those important critical devices in our network, servers, switches, router, firewalls, they cannot have running IP. They cannot have an IP that changes from time to time. So that would need us to configure static IP. Yeah. Now, we do not use static IP for users' device because users can be many and they come in and out from the network from time to time. Because if you use static configuration, every time the user comes into the network, you have to use to configure manually on their IP and their device, then you can cause human error and also duplicates. Now, in our laptop, how do we configure statically the IP address or automatic IP address? You just go to TCP screen, IP protocol version 4, click properties, and you can see there are two options to choose from. One is to use DHCP, obtain an IP address automatically. The other one is static configuration. I believe you have done this before, so it's not strange to you. Okay, types of IP addresses. So the first one we already know, network and broadcast. Now there's another special address which is 127.0.0.1. Now that is called loopback address. Now 127.0.1 is me, my device. Every device have this IP. Okay, now you can actually ping your own IP. Yeah? Can go to command prompt. Now, if I type IP config, that means I know the IP that is being set by the network for me. So I have a Wi-Fi that giving me IP 192.168.101.24. Now, this IP is what is being set by the network and is given to us. So that is also a host IP that I have. However, there is another IP that every host would have, that is 127.0.0.1. So if you ping, you are pinging yourself. And it should work, because your laptop is functioning. So actually, 127.0.0.1, you're pinging yourself. And they call it loopback. Now, why is it called loopback? It has something to do with your TCP IP protocol stack. Okay, since we have all those from network background here, this is what happens in transmission, okay? So, oops. This is my PC. And each time we would want to send data out of the network, our device will actually go through the protocol stack and does encapsulation. So he will create a data and then he encap with the addresses and then he will send it out, right? And the sending out is going through a cable or a media. However, if you Okay, let's say we ping someone else. Like I am 192.168.10.1, and I'm pinging a 192.168.10.2. So that means I am pinging another device. So what happens in my PC is it will create a packet, put an address, and then send it out to the network to the other recipient. So it goes out from the protocol stack. We call it protocol stack because it does encapsulation, yeah. But when you ping a loopback address 127.0.0.1, it will still create this packet. It will go through the encapsulation process, but it won't send it out to the network. It will send it back. So that's why they call it a loopback address. Right? Encapsulation, you all know, right? You from data, put header. We did it during our first session. Then out through the media. Send it to in the route to another destination. But this time when you ping a 127.0.0.1, that means ping yourself, it will still create this, but then instead of sending it out, it loop back into your own PC. So that's why it's called a loopback address. It's our own loopback address. So they use this loopback address to test your protocol stack to see whether this is working or not. So if it's working, you can see a ping reply. Okay. The other address is what we call a link local address. A link local address, yeah. Now, if you try out in our lab, you have your laptop, then you go and connect with our EDS 4008. And here, at this side, you configure as obtain IP address automatically instead of using static. Normally we use static, isn't it? We want to talk to our switch, our EDS 4008, we will configure 127 dot something, But this time you don't configure, you just put obtain IP address automatically. Okay? Then Windows would actually detect that you connect to a device, and then he find that there is no DHCP server because you actually configure it to obtain from DHCP, but there's none. However, the connection is there with this guy, right? So what Windows will do is, he will assign you an IP address from this range, 169.254 range to 255. And this is called a link local address. Okay? You can try it. I tried it before there. So I connect my laptop to our switch, and I refuse to configure statically IP address, and I just select automatically configure IP address. Then Windows detect, the connection is on, but you don't have IP, and there's no DHCP server, so I give you a link local address. But of course, it doesn't work because your link local. Now we know that now since we know about network address and its range of nodes, IP address, if your IP address is not in the same network and there's no router, you just have a direct connection, they won't talk to each other. So that's why when you are connecting to a EDS 4008 with 192.168.127.253, you need to then configure your own laptop with in the same network range, the IP from the same network range. Yeah, but you can see this happening where Windows will assign you the link local IP, which doesn't work, okay? Because that is how it's meant to be. The DHCP client in the Windows will self-configure itself. Then there is another special IP address, which is testnet. If let's say you create a training network for training, you can actually use this IP address. You can set 192.0.2 range just for the training network. But normally we'll just use 192.168. experimental address is 240 onwards, which we can use for experiment. Okay, just on this note, if you found yourself in the network, suddenly you connect to a network. Yeah. And you want to talk to another device in the network. First of all, you must know the network address of this network, and then also the mask. Now, if you do not know the network address of this network, you can do an IP config in any of the devices. So when you do an IP config, you would know their IP address and you calculate their network address. Right? So for example, if you do an IP config and it says 172.16.21.100 is my IP and my subnet mask is /24. So from this information, you can calculate your network address 16.21.0. So you know that this guy's network is this, right? And then we also know that you can also calculate its broadcast. So 172.16.21.255 is the broadcast. True? True? Because why? It's /24. So if I take the /24 and act it upon this IP, this is a host IP, yeah? And we know that /24 is the first 3 decimal. And how do I get network address? Is when I turn the host bit into 0. That is network address. And how do I get broadcast address? I turn the last bit all to 1. So 1255. So therefore, I am able to calculate their network address and broadcast address. And from there, I would know we are working backwards, the host IP range, which is 21.1 up to 21.254. And this guy is .100, right? Now, if you want to plug yourself into this network, then make sure your IP is within this range so that you can talk to it. So that's why when you connect to your EDS 4008, who has the network address or the IP address of given by MOC size 127.253, you got to, and it's /24, yeah, if you look at the configuration, then you got to configure your laptop into its range. Right? Yeah. So then you know that your laptop can be 127.1 up to 127.254, but avoid 253 because MOSA uses 253 for switches and 254 for router. So basically, these two addresses, we don't use it to configure for our laptop. So that's how it is. For DORBOT, it's the same. So when you read your DORBOT IP, then you read, I know you missed the first part. So then you read the subnet mask. Then that's how you have to configure your laptop in that range to talk to your DORBOT. But we are not so concerned about overlap is because we are talking one-to-one. So the only overlapping IP is with that device IP itself. But in the whole network, it's a different scenario because then you need to know all the other devices that's available in that network. Okay? Now, there actually is a practical lab, but we can do this offline. Yeah. It's actually packet tracer with some nodes. Then you can just choose the IP address, network address that you need, and then configure the IP addresses into the nodes, the router and switches. Then we do a ping test. Okay, so for the summary for today, so we have learned IP address as a unique identifier, the use of subnet mask to indicate network ID and host ID, And how do we calculate and determine network address, host address, broadcast address in the network? We also see the range of private IP that we can use for our network design. Okay, the rest not in that range, don't use it, yeah. That is for public IP. Unless you are in the telco company, then you are dealing with the internet, then you have to use public IP. Okay, so we also look at classful and classless address, where it's determined by the mask, fixed mask, and the range of first decimal in that address. Then we talk about network design. How do we design IP address for certain subnet? So basically, you look at the network size, then you choose your class that you need or the mask that you need, and then take from the IP address, the private IP range. Then how do we configure IP address? There are two ways. One is static, the other one is using DHCP, and we also look through the types of IP addresses. And lastly is the lab. Okay? Any question? Yes.
Why class D is reserved for multicast?
Sorry? Why class D?
Is reserved for multicast?
Yeah, it's just a standard that they use it they just decide to specify a range for multicast. Yeah.
Can I build a class B network inside the class A network?
Yes, can. So for that purpose, we call it subnetting. So you have a class A network, then after that you decide to make the smaller subnet of our class A. Then there's another topic we can discuss, it's called subnetting. So basically that is my next class with you all. It's called subnetting, and the other one is called VLSM. So from a big network, we then design smaller subnets from that big network. Just like what you say, you have a class A network which is very big. Then from the class A, I want to design class B, class B, class B, class B from that big class A network. So we call that exercise subnetting. From big network, we make into smaller subnet. So that is a technique to design the network address and find the address range for each of the subnet. Okay, it's called subnetting. Yeah.
Then why we need to have the link local address?
Why do we have to have a link local address? Just because that we have an IP? Otherwise, the IP would be none, 0.0.0. Yeah, so Windows actually have a DHCP client that will just allocate the link local address to its interface.
So they want to avoid something.
No, so that you have an IP. Yeah.
Must have an IP.
Yeah.
I want to ask.
Yeah.
For like the subnet and the IP address, right?
Yeah.
When we turn into binary,
Yeah.
let's say, for example, we put a random IP address on a random subnet. For the binary, it doesn't, let's say, it's /30//29.
Okay, 29.
It only takes the front 29 binary of the entire IP address. Is that correct?
Correct. So that is the network address.
So it doesn't matter if the front part has any zeros or a different type of, let's say, 10.111.1.0.0.1.1.1, something like that.
Yeah.
Is that still fine?
Yeah. For node IP address, it has to be a random 0 ones.
Okay.
Yeah.
So it doesn't matter if there is zero, if there are any zeros or ones, just that the first 29 of the binary is taken for the /29.
Correct. So that is for the node IP or the network address. Only the subnet mask, then you have to have all the ones and then zeros. So that is the subnet mask. Yeah.
0.0.0 is for default route.
0.0.0.0. Okay. when we talk about routing or static routing, 0.0.0.0 means any network. It's not actually an IP address, it's meaning any network. So when you do an IP routing, that is another topic, it is called static route. So static route is actually you are telling the router that you can access to or send packets to the other network or any network. Okay, so let me draw. Okay, this is your router lah. Then there would be another router that goes to another network. Yeah. So let's say this is network is 10.1.1.0/24. So then your router, if you want to configure a static route, then you actually use a command IP route. And then you got to tell your router a network address. And you got to tell your router a mask, network mask for that network. And you got to tell your router which gateway IP to be used. We call it next hop IP lah. Okay. So therefore, let's say this is my router. This is my router. And I want it to send a packet to 10.1.0 network. So I would then configure in my router. Sometimes my pen disappears. Okay, so IP route, I would configure into my router 10.1.1.0 and the mask is /24 255.255.255.0 and then the gateway that I have to use to go to that network. So normally it's my next route, next gateway that I'm connected to lah. So let's say this connection is 192.168.1.8.30 connection. That means this is .9 and this .10. So I would use the gateway 192.168.1.10 to reach there. So you're telling your router, in order to send packet to the other network, it has to use this gateway. So this is the command. Now, what if there are many other networks here? That means any other network, I also want to use this gateway. So then your command would be IP route, any network, any mask, then use this gateway. Which means now, in order to send this packet to any other network over here, I don't care what is the network address, and we also don't care what is the mask. Any is a wildcard lah. Any. So that is 0.0.0 to the next gateway, correct?
So a gateway, when you receive something he wants, just drop it.
Not something he doesn't want. It's something that is not inside the routing table.
It's not.
So let's say when let's say laptop send the packet to the router.
Okay.
It doesn't know which one, and then
It will drop.
based on the
Routing table, correct. So let's say your routing table don't have this route. You only have this 10.1.1/24 network. Then your PC is sending to 10.1.1.100. The router will take this and then he will start to calculate, hey, this IP is in this network, right? This IP is found in this network. It's the range of this network, right? Then the router will say, oh yes, if you want to send to this network, anything inside this range, I can forward it to my next gateway. So this guy. But let's say now the PC is sending to another IP. And that IP, let's say, is 192.168.2.200. Now, the router will take this IP and then he will check against the routing table entry he has. And then he say, hey, this IP is not found in this range. And that's where he's going to discard.
But if still have the 0.0,
Yes.
it will still forward to the
Correct. If it's 0.0, then the router say, okay, it's not in this range, but it qualifies, satisfy this range, anything, and then you send it to the next gateway, so he will forward to the next gateway.
What if the big network still don't have this range 192.168.2?
192.168.2, and there is no default route, he will drop.
I mean, I have default route.
You still have default, then you forward, keep on forwarding. Forwarding, and then there's a problem. Then it will go around the network. If really in the network there's no such this network around, then it will keep on forwarding around and around the whole internet.
Keep forwarding.
Yes.
Oh.
That is why we then
If keep forwarding, then no one will drop the packet. Then
no one will drop a packet, and therefore it will crowd the internet. So therefore, inside an IP header, there is a field called time to live.
Oh, okay.
Yeah. So you set the field time to live to a certain limit lah. That is how many hops you can hop. That means this packet can hop how many times before you throw it away.
But default is normally it's 30 hop, right?
32 is the 2 power of
Oh, okay.
32 or 64. Yeah. Yeah. So if they keep on sending from router from one router to the next router, he will minus 1 first. So let's say you set as 32. So by the time I send to the next router, it's 31 hop left. Then the router, after he forward to another router, he will still minus 30, and then minus 29, 28. So the last router who got TTL1 right left, and then he wants to forward, right? He wants to forward, he says TTL minus 1, 0. So I cannot forward anymore. I discard.
So who decides this? How many hop?
The TCP IP protocol itself actually has a default value, but we can also set. But we can also set.
By default, is normally is
32 or 64, yes, you're right.
So you say just now you mentioned we can set from the sender.
Yes, correct. Correct. Yeah, you can set from the sender. Yeah.
Now I know usually what I get usually when I change someone.
Yeah. So
TTL those terminology.
yes. Time to live. Correct. It's called time to live. Correct. Okay, good. Any more questions? Yeah, you can ask.
Let me explore more.
Okay. Yeah, just now we talked about ping. We can actually look into that. Okay, ping. Let me see. IP config first. Okay, so there's a router. So I'm going to ping around my router 101.1. So this is the ping. Yeah.
64 milliseconds.
TTL 64. Yeah, time to live 64. So they set it at 64. And I ping a router, that means it just go to the router, haven't moved on. Yeah. Okay, so it hasn't moved on, so it's TTL still 64. And then it sends a 32 bytes data to that router, and that router replies back to me is yes, I got your packet, and I send it back to you, and the time to travel from you to there and back is 8 milliseconds. So the first time is 8, 1, 2, 3. So it's quite stable one.
Okay. So you can only maximum hop 64.
Yes, in this case. You can change. Yeah. In fact, we use ping statistic also to read the network connection quality lah. So if I ping to Google, so this TTL is how many left over when it comes back to me? It's 117. So we can more or less guess 128 is the value lah. that they set. So 128 minus 117. That means this is how many hops it has hopped before it reaches to me. Yeah, and then you see that my first one is always slow. 100 milliseconds before it goes. Then our network is 5 to 6 milliseconds. Yeah. So that is one of the density. So ping, you can also use it to look at how stable or the quality of connection is. Now, if you see the average time is almost the same, then it is not too bad. But you see like this 6811, something is causing the delay. So normally, if the network connection is quite stable, you shouldn't see a large difference. You see like 675 is okay. But suddenly we have 68, there's something happening here. Yeah. And if our firewall allow it, we can also trace route. If our firewall allow, or trace route is trace.
Normally ISP will hide their IP for security reasons.
Yeah, if that's why it depends on the firewall. Yeah, but if it's allowed, you can actually see what are the router IP that we have hopped. Yeah. Yeah. So let's see whether our ISP allow us to see the next IP. Yeah, it does. Okay. So therefore, you see, we know that this internal 192 private. Internal, and this one is out.
The
Public, because you see 202 is not in our private IP range anymore. And yeah, not allowed to see. They hide, not allowed to see. But the rest you can. 72. So you see all these are public range. So basically our packet is hopping to all these routers in order to reach Google 8.8, then reach. And if you use the web, you can actually check where are all these location of this IP. Yeah.
Oh no.
Yes. So you can
Malicious intent.
yeah. Oops. Okay. So you can ask I think who is my IP? Or what is my IP, sorry. Yeah. So they do detect 202, which is our first public IP. 184.48.1. Oh, okay. They may have used a... Okay, and then you can... Actually, there's a site where you can enter the IP address. Okay, let me... So you want to know where this is, you can actually ask them. Who is lookup? Yeah. IP address lookup. Yeah.
We go find your house.
Yeah. It's still in KL. Okay, so we can find, yeah, maybe further away. 142. Where does it go? Public IP. No mention, so it's not there. Let's look at this 172. In fact, there's a visual site as well. You can find a visual trace route from the internet. They will show you the path that it goes through. Yeah. Yeah, it's in Mountain View, already in California. Yeah. There's another visual trace route. I hope the website is still there. But it's tracing from yeah. So
I changed I close Wi-Fi.
yeah. So you can actually use the visual trace route. It will trace from a server in US lah, actually. Then you can see the packet flows to another location. Yeah.
Very angry.
Okay.
Wow.
Yeah.
From Europe to the States.
Yeah, it's actually traced from the States because this server is from the States. So you can trace to Malaysia, then you can see where it goes to. Malaysia, okay lah, trace Star College.
The guy is saying
DDoS.
they're already blocked, right?
Is it?
Never say never.
Do they
The website got hacked before.
do they take domain name? Let me check. Yes, they do. There.
Maybe you can try www.mmu.edu.
MMU.
MMU website got lazy.
There.
Friends.
What did it go to Malaysia? Did it go to Malaysia? Where did it go? No, like it stopped somewhere. It stopped on 10. Then it doesn't move on. It starts until here and then it doesn't move. He couldn't get the next hop. Yeah. Maybe try star. Tak mai. Oh, tak ada. No lah, somehow it doesn't get past through US. Then the rest cannot see you. So they only trace up to here. Okay. So I think that's all for today. Thank you for attending.